Alright, we're going to deal with a system again, which means I have more than one equation to deal with. This time we're going to talk about a linear, right? So y equals mx plus b, and a quadratic. And we want to find out where they're going to cross at. So a couple things we have here. Two scooters leave a stoplight at the same time. Blue scooter accelerates and then travels at a constant speed. So we're talking about something linear, constant speed. So here's blue. Red scooter accelerates at a constant rate. Okay, constant rate. So now we're talking about quadratic. The distance d in feet. Each scooter travels after t seconds is shown. When does the red scooter catch up to the blue? Explain. So here's what we're taking a look at. We're going to set these two guys equal to each other. So d equals 40t, and that is also equal to 4.5 t squared. Okay, so what I don't need is the distance at all. So we're trying to find the time in which this is the same. So most likely we're going to start by subtracting 40t. Now these are unlike terms, so we hop up here so you can see 4.5t squared minus 40t. So what we're doing right now is we're looking for the greatest common factor. Now that we have that, we're going to take a look at it. I know t is going to be the part of the greatest common factor. What I'd like to do is take 5 out as well, just to reduce the numbers. Don't have to, but it will help out a little bit. Minus, what do we got here? 40 divided by 5 is 8. So this is equal to 0 now, because we had everything on one side. So 8, and my 5t equals 0 gives me t equals 0. So that means that's back at the stoplight, right? So my time was 0, so at the stoplight they were the same. So now we're going to take 0.9 t equals 8 if I add that over, and divide by 0.9, divide by 0.9. So 8 divided by 0.9. And so 8.8 repeating. So the time is 8.8 repeating seconds. Okay. So that's how much time it's going to take for them to be the same. And we could just throw it into either one. So 40 times 8.8. So we're going to be out 355.5 feet away from that stoplight. Okay, so at 0, of course the distance was 0, so they're the same. So what we're really doing is just trying to use all those old skills of systems, and we're going to put it all together. Before we get too much further, what we're going to do is understand some basic concepts here. That if that linear equation goes through that quadratic, we're going to get two solutions. They're going to cross over at two different points. So we see that illustrated here. If it's going to hit just at the vertex here, then we get one solution, so we only get one solution. And if they don't intersect at all, I have no solutions. So we have one solution, two solution, no solution. So those are the only three things that can happen. There's no other possibilities here. A line can only go through and hit at most two places. So as we're trying to do these, we might run into a no solution. So just like we had no solutions before in our systems, that may happen again. So the if we were to graph these two, I would find that 0, 0, they cross over, and our time in feet, so 8.8 repeating and 355.5 feet. So that's where they're going to meet up and cross over. So next item we'll do is take a look and just review a little bit of graphing with this. So so the linear part, not too bad. We got 2, and we're going down 1. Alright, so we get plenty of points here to make sure our line's nice and accurate. Next thing we'll do is we'll take x equals negative b over 2a. So that is 1 over 2 times 1, so 1/2. So the vertex 1/2. And now we're going to put that 1/2 in there. So 1/2 squared minus 1/2 minus 2. So that's 1/4 minus 1/2 minus 2. So 1/4 minus 1/2 is negative 1/2, or 1/4, minus 2, so negative 2 and 1/4. So we'll squeeze that negative 2 and 1/4. So there's my vertex. So of course we're talking about, we're going 1/2 and going negative 2 1.25. So you see why solving algebraically is usually going to be our main method here, because this is going to be a little bit tougher to try and graph and keep it really accurate. So there's my axis of symmetry. And we want to get some more points going on here. So with my equation, I'm going to plug in a 0 and get -2, and then take the reflection of it. So 0 and -2 and the reflection of it. So let's try, let's go ahead and get another point here. Let's try, let's go with 2. And see if we cross over that linear line yet, right, my purple line here. So 2, so I have 4, -2, -2, so there's 0. So at 2 we're at 0, so we found a point of intersection and the reflection of it. So we should be back here, so a half, 1, 2. So somewhere over here we're still going to get that other one. So maybe we try 3 as well. So if I clear this out, so all we're doing is substituting values in here so we can solve. I have 9 minus 3 minus 2, right? 3 squared. So 9, 6, and then 6 minus 2 is 4. I'm also going to get the reflection of it. So 3 is 1, 2, 3, 4. And -3, 1, 2, 3, 4. And it still wouldn't get us our last point, because linear we're going to be right here, so we're going to meet out here someplace. So we start to build up that parabola, trying to find those points of intersection. Come back to the purple here, and we'll go ahead and do that. So we're finding those points of intersection. Just missed that point there just a little bit. So finding our solutions that way. So a nice clean graph. Let me pull this clean graph out of here so we can see. Oop, not that one. And we'll get that over here. Alright. Board's getting a little confused here. Alright, so here we got our 1 here. We have our -2 here. They meet up nice, and we see that back here just a little bit. So accuracy the key. So what we can see here is graphing is not going to be the best way to do it, but I do want you to try one more. Remember how to graph these guys and put them together. The other thing we want to do is just recall what we did in the first problem, solving those systems. And remember, we talked in solving systems, when you have y equals and y equals, set the other two parts equal to each other. Why do any other work? So we have 20x plus 24, 124, equals -x squared plus 39x plus 64. Let's get everything on one side. Minus 20x minus 124. I got 0 equals -x squared plus 19x. We're going to be minus here. Um, 60, and let's go ahead and clean up signs. I have negative out here, so if I just divide by a -1, doesn't change anything over there, fixes everything that I need here. So 0 equals x squared minus 19x plus 60. Do I have factors of 60 that add up to 19? Alright, so you betcha this is going to be factorable for us now that we work that out. Our factors are going to be x minus 4, x minus 15. Okay, that multiplies to give me 60, adds up to 19. Signs are the same, so x equals positive 4 and positive 15, so let's plug them in. Always going to be easier to plug them into our linear. So we had 20x plus 124. So 20x plus 124. I need to do 20 times 4 plus 124, and 20 times 15 plus 124. 20 times 4 is 80, so here we're looking at 204. So 4 gets paired with 204. 15, so 15, and we're trying to get its pair as well. Should be 424. 424. Oop. Why I wanted to write the 2 there. 424. So those are the points in which we would cross. So definitely want to make sure we have a way to do this algebraically instead of graphing. Again, usually we run into these type of problems. Just talking about attendance at the local pool, that sort of thing. Right now we're concerned mostly with the math. We want to understand the problem when we're done with it. So X is the number of days, so X is the days, and Y is the actual attendance. So again, trying to get these guys set equal to each other. So equals 32X plus 74. Alright, as we solve, you can go either way you want. Negative x squared. Let's subtract 32x. 32x and minus 74. Minus 74. I'm just trying to get everything on one side. So now I have plus 7x. And we got minus 10 equals 0. Again, we're going to take care of this negative 1 by dividing the whole thing or multiplying either way. Minus 7x plus 10 equals 0. And do we have factors of 10 that add up to 7? You better believe it. X minus 5, x minus 2. Okay, if I didn't have that, what we could do is do the quadratic formula. So x equals 2 and 5 when we solve here. And we're going to plug it in. So I need 32 times 2 plus 74. 32 times 5 plus 74. And we're going to get some grand totals here. Here we got 64, and we're going to tack onto that. So 138. So 2 gets paired with 138. 5, let's get our second ordered pair where they cross that. 5 times 32 plus 74. 234. 234. And so here are our points of intersection. So that means on day 2 and day 5, Pool A and Pool B had the same attendance. On day 2, it was 138 people. On day 5, it was 234 people. So I'm guessing on day 5, maybe it was a little bit hotter, something like that. Okay, so if we drop everything else from it, we can do systems here. Notice that we're not trying to line everything up. I can't just eliminate what I'm trying to do here. One other method that we do have is just to take these guys and subtract. Just keep in mind this is actually plus 4 over here, and I can scribble it out here. So when I subtract y minus y is 0 equals x squared. Negative 6 minus 1 is negative 5x, and 10 minus 4 is still 6. So just an extra method that we have. We've already talked about elimination, and that's what we're doing. We're eliminating. We can always set y equal to y. That's not a problem. But one other method that we have, just to go ahead and subtract our y's, let's go ahead and factor it out. X minus 2, x minus 3. And I do want to go back and actually plug these in. So x equals 2 and 3. And if I clear up some of this mess up here to see what I did. Alright, let's plug it in here. So I have 4 minus 2 gives me 2, and 4 minus 3 gives me 1. So 2 pairs with 2, and 3 pairs with 1. Right, here's getting the y values right here. And we were substituting in 2 and substituting in 3. Okay. Systems of equations. Okay, so same thing. If I want to use that second method we talked about, what I would do here is add 30 and add 30. So these guys are taken care of, and now I have y and y, so I can subtract. So I get 0, and I'm going to get negative x squared. I have 12 minus 11, so plus x. And I have a double negative here, so plus 42. Keep in mind, you can always just disregard what we're doing there and just plug it in, or set y equal for both of them, so you don't have to worry about it. If I end up with negative a value, the next thing I'm going to do is multiply by a negative and factor as a 42 that subtract to give me 1. Minus 7 plus 6 equals 0. X equals positive 7 and negative 6. And of course I want to use my linear equation. I want to clean some things up here. Alright, so we got y minus 30 equals 12 times 7. Y minus 30 equals 12 times negative 6. I'm going to get these guys so I have an ordered pair, 7 comma and negative 6 comma. We'll get you an extra second for your calculation here. So 714, negative 6, negative 42. So notice what we're talking about here is just a solution to the system. We're not dealing with attendance and days and stuff like that like we were in the word problem, because attendance couldn't be negative 42 on negative day 6 of the pool opening, stuff like that. So always make sure that your answer makes sense. Our answers did make sense for days and numbers for the pool, so we didn't have to double check it there. Solve with the graphing calculator, so we can show you how to graph both of these and then take care of intercepts. We'll do that in class. What I do want you to do is to do these by hand so that you understand that we got the answers correct. Okay, and just a little lesson check. So use a graph. So we do want to use a graph mainly to remember how to graph our quadratics. Remember x equals negative b over 2a. And we'll give you that tip on how to do this on the graphing calculator. So we'll save number 4 as an extra example. We don't have to do anything with that. But let's take care of all these. Make sure we understand what's going on. So we want to take care of all of these system. So big idea in 6 here. So you want to make sure that to get no solutions, remember they don't intersect. So if I have a parabola that opens up, I want to make sure that linear equation starts below it. So remember what we talked about with the vertex and where to put those to get that to work out. So it should have a few questions, but should also be very functional as far as getting done what we're trying to get done. But as far as big concept, we might have a few questions, and that's what class time is for. Okay, do have some homework tacked on here. I'm going to give that a whirl. You may solve using elimination or substitution. Either way is fine by me. Some people don't like to eliminate by subtracting. 6 of these, half dozen of those. As long as we're getting it right, I'll be happy. Alright, later.